known as Teach as we learn. Today we're going to be learning about exponential functions. So let's begin. So on the board, I have two formulas. And one formula is probably really familiar. Yes, I'm bringing back the slope formula. Right? Slope formula, but the formal name for this is all called linear functions. But you know, formula is called slope formula. And then this formula, which we have no idea about, but it's not much different, but yeah. So let's think about linear functions. So linear functions, there is a slope and y-intercept, right? And the slope is either used to add or subtract. Yeah, that's I think much about it. About the slope. And then when we graph it, it looks like a line. So meaning that, let's say if you have to graph y equals 2x plus, 1, then we would start at 1, then we'd graph it, 2x. So it'd go as this, 1, 2, 1, 1, 2, 1, and then we could sort of envision that line going down like that. However, and this is pretty much all about it with, linear. However, with exponential, it's not that different. But there's the y-intercept. Our A is our y-intercept. And B is our slope. But in this case, our slope is used to multiply or divide. And I will give you an example of this, right? This is the part where we're going to go more in depth because this is new, right? This was just a little flashback review, but this is the part new. So maybe if I give you formula, so let's maybe write y equals 6 times 2x. So let's, sort of plug in coordinates within. So 0, right? 0 is our x. Well, obviously, if our y-intercept is 6, then it would be 6. And 1 is our x. So let's now plug in that. Oh. So 0, 6, and 1. So 2 to power 1, right? So x, it's 1. So 2 times 1 would be 2. 6 times 2 would be 12. Then 2, right? So 2 to the power 2. Then this would become 2. So 2, right? 2 to the power 2 basically wants us to multiply 2 times. So we're going 4, then 6 times 4, 24. Then 3. So we plug in here, and then we would times this another time. And this becomes 4 times 2 becomes 8. And it would become 8 times 6, which is 48. So basically, remember all that multiplying exponents? Here, you just multiply it here as well. So when we graph these three coordinates, instead of getting a straight line, we get something like this. I graphed it on Desmos, right? Same equation. And it's not a straight line. You could tell this is, easily curved. We see it here, and it's a curved line. Well, since it's exponential, meaning that it multiplies by 2 in our case, then we won't get that straight line. And so basically in exponential functions, it's not a straight line. And many teachers will be like, is this a linear function or exponential? And they'll show you like a curved line graph like this. Then you know it's exponential, because exponential functions are never ever straight. If it's straight, those are linear functions. But this is sort of the difference between linear versus exponential. And exponential functions, basically, this is our formula. So maybe I can even actually do it one more time just so we get the hang of it. Let's do maybe y equals 4 times 3. Haha, even I'm getting a little messed up. 3 to the power of x. So first coordinate would be 0, 4. 4 is our y-intercept. Then 1 would be 3. So 4 would be 12. Then 2. So it would be 3 times 3, right? If we put 2 here. And 9 times 4 would be 36. Then let's do 3, right? Instead of doing x, we want 3. So we want to multiply 3 times. 3 times 3 would be 27. And then 27 times 4. What is 27 times 4? 27 times 4. 108. Okay. And then we would graph this, and then it would show a curved line. So there are 2 types of exponential functions. One is growth, and the other is decay. And yeah, they're exactly what they sound like. So with growth, it basically grows, right? Like what we had 0, I believe was 4. Yeah, 4 and 1, 12, and 2, 36. Right? These numbers are growing. The y values are growing as the x increases. However, in decay, it's not like that. Suppose this would be 0, 4. Then this might be 1, 2, right? How this is timesing by 3 as like the slope, or this is like timesing by a half. So the next would be 2, 1. And that's literally an example of each, right? And that's all what growth is saying. It's saying that if the slope is greater than 1, then that's growth. If it's less than 1, it's decay. And then obviously if it's 1, it's like not doing anything. But this is literally all it's saying. Quite an easy concept. Growth. So since it's growing, the graph would look something like this. Actually, just erase this all. So since it's growth, it would maybe look something like this. And if it's decay, instead of starting from 0 or starting from the bottom and then going upward, it is starting upward and then going downward. Still are curved lines, but that's different directions. So that's all what growth and decay is about. Teachers like to ask that, and they might give you a graph and say which one is growth or decay, or they might give you the slope and be like, what's the growth and decay here? So that's pretty much it, right? And yeah. So that's it for today's video. I hope you enjoyed. I hope you learned and benefited from it. If you do have any questions, comment them down below in the comment section and I will reply to them.